Hi guys, so for today's lesson on Arduino, we explored already how you can add light to an art project and make it more interesting. Today I want to talk about how to add motion to a project to make it more interesting. So sometimes you can really add something to an art project if you have flowers that bloom, or puppets that talk, or figures that rotate, or something like that. So if you're interested in adding a little bit of animatronics to an art project, a servo is a great way to do it. So let's learn about servos. I'm going to introduce two new components in here. One is the push button, and the other is the servo. So we talked about potentiometers before, and a potentiometer is an analog sensor, so it can read any value in between 0 and 1024 as you turn the knob. A push button is a digital sensor, so it really only has two states. Button is up or button is down. So they just work a little bit differently than a potentiometer does because there's only two possible states of the sensor, either up or down, and we read it a little bit differently. So we're going to start with a push button, and if you're working with the real-life Arduino in your kit, you probably have a couple of these push buttons with colorful tops, or they might be black and white, I don't know, but they should be in this kind of form factor. So I'm going to rotate mine. So there's two pins coming off one side of the push button and two pins coming off the other, and I like to make those straddle the valley on the breadboard. So you take your push button and make it straddle the valley there. Usually, the way that these are laid out is that the buttons that are now across, or the pins, sorry, that are across from each other over the valley, those are connected all the time. There's just like a wire going across that connects these pins. So if you connect something here, you're also connecting something here. However, the pins that are adjacent to each other in different rows, those are not connected. But if you push the button, then they get connected together. So it's just a switch inside, and when you push the button, the switch snaps shut, and the switch will connect this row of pins to this row of pins. So the way that you work with them with Arduino is we're going to put 5 volts on one pin through a resistor, and put ground on the other pin, no resistor, and then we're going to be reading the pin that's closest to ground. So this is what that looks like. You're going to look in your kit for the resistors that say 10K on them. So look for the 10K resistors, and in Tinkercad I'm going to grab a resistor and I'm going to set it to be 10K. So the units are already set to kiloohms. We'll make that be 10 kiloohms. If you can see the colorful stripes on these resistors, they should be orange, black, brown. But you may not be able to see them super well. The blue is hard to read. So I'm going to rotate this a little bit. There we go. And we'll take this resistor, and I'm going to go from one of the pins in the same numbered row as the lower pin on the push button. And then I'll also connect that resistor to the plus rail of my breadboard, so it's powered. I'm going to make that wire be red, even though that's just a resistor pin. So that, bend the resistor over, put one leg in the same row as one of your push button pins, and put the other leg in the plus rail of the breadboard. And let's go ahead and wire up power to the power rails here. We'll go from 5 volts to plus, and I'll make that red. And then we'll go from ground to minus, and of course I will make that black. Okay, so our power rails are powered, and just make sure push button, resistor, going to the plus rail. All right, we are going to take the other pin of the push button, and we're going to connect that to ground. So take a wire and go from the upper numbered row of your push button, connect a jumper wire from there to the ground rail. So the resistor is a super important part of this circuit, because if I snap the push button shut without the resistor, I'm going to make a short circuit. The electrons are going to flow super fast between 5 volts and ground, and I may damage my Arduino. So the resistor slows down the electrons enough that it won't cause any damage. It's just like a little load in the circuit that will make it so it doesn't damage it. And then, lastly, this is where I'm going to connect this to the Arduino. So find the same numbered row where the resistor and the push button pin are. It can also be in this numbered row. It doesn't matter. They're all connected when they're used with the push button. But grab a wire from that numbered row to, let's use pin 4 on the Arduino. And that can be any color wire. So the way this works is pin 4 is going to have 5 volts on it when the push button is up. But as soon as you push the push button down and you snap the switch shut, then the ground wire becomes connected more directly to pin 4, and then it will read low as soon as you push the push button shut. So it's high when the push button's up, and low when the push button's down. In order to code this, we're going to get a servo, and we can make the servo turn when we push the button. So let's grab a servo. Whoops. Servo. Here's a little micro servo. This should be pretty close to the servo that you have in your kit, and I'm going to rotate it just a little. There we go. So they didn't color the wires on this servo, so you'll need to look at the colors of your wires on your servo. The connector has a red wire, and then it has a wire that's either black or brown, and you have a wire that's either yellow or white. So those three wires are: the black or brown is ground, the red is power, and the yellow or white is data. So the red one's really easy to identify, and on mine the red one is the middle connector. So I'm going to connect power to the plus on my breadboard. And I'll make that one red because it's connected to the red wire of the servo. And actually I can see now that I click off of it, these are colored too, so that's helpful. The black or brown, you're going to insert a jumper wire into that connector, and that of course is going to go to ground. So I'll make that one black. So the brown, ground, red, 5 volts, that leaves the data wire. The data wire needs to be connected to some pin on the Arduino that has a swirl next to it. That swirl stands for pulse width modulation, and like we talked about with the NeoPixels, it can pulse a voltage really fast. The servo requires that because it uses a pulsed voltage to know how far to turn the servo. So we're going to use pin 9 for this. So grab a wire from the white or yellow pin and go to pin 9 on your Arduino. And I'll make that one be yellow. Okay, so now you've got everything all wired up. Let's go ahead and pound some code. So I'll go to the code part here. And it's got my default Blinky code. I'm just going to get rid of this. Goodbye and goodbye. We'll start fresh. Okay, in order to use the servo also requires a library to be installed. So as we did with the NeoPixels, we're going to need to add a library for the servo. This library is already built into the Arduino environment, so all we have to do is include it. In Tinkercad, you click on the little file drawer, and you find servo, and you just click include, and it adds this little line to your code, and you're good to go. If you're in the Arduino environment, you're going to go to Tools. I lied, it's not Tools, it's Sketch. Sketch, and then do Include Library. And I found that I had to scroll down quite a bit. Under Contributed Libraries, there's a thing here that says Servo, and just click on that. Okay? In Arduino Create, I'm not 100% sure where the Servo library is, so you may need to browse for it a little bit, but you'll need to include the Servo library. Alright, so that's how you include the library. So next, we're going to first work with the button, and then we'll make it adjust the servo. So to work with the button, we're going to make a variable close to the top of the code, and we'll just call it btn for button. It's of type integer. So int btn semicolon button. We don't need to do anything. Actually, I lied. We do need to do something in void setup. We have to set pin 4 to be an input because we're using it like a sensor. So we'll do pin mode 4, input. And then inside void loop, we're going to read the state of the push button, and I'll show you what that looks like. So we'll say, so now that we've got our variable declared up there, we can set it to a value, btn for button equals, this is not analog read, it's digital read. And then we're going to read on pin 4. So one structure I'm going to teach you about is the if statement. An if statement works where it tests a condition, and if the condition is true, it runs code. And if the condition is not true, then it skips that code. So the way the if statement works is like this. If btn equals 1, and then you have to have a set of curly braces. So it'll read the button from the digital port, and that value is going to be either 1 or 0. It's not a number from 0 to 1024. Digitals are either 1 or 0. So if it gets a number that's kind of a high voltage, it'll snap it to 1. And if it gets a number that it can round down to 0, it snaps it to 0. So inside these curly braces are the code that will execute if it's high. Now remember, high is when the button is up. So this is like its default state. And then after this, we're going to do an else and another set of curly braces. And the code that's inside those curly braces is what will run if this condition is not true. So if the value of the button is down instead of up, it'll execute this code. Okay, so this is where we're going to mess with the servo, and we'll go ahead and add that next. Go back to the top of the code, and now that we've got our servo library included, we're going to make a variable of type servo. This is a capital S servo. Servo, we'll call it S, just to make it simple, servo S. There is something you need to do in void setup, and that's attach it to a pin. So you say s dot attach, and then we've got our servo connected to pin 9 right there. So 9. Okay. So in order to set the servo to a certain angle, there's a really simple command to do that, and it takes the angle in degrees, which is unusual. A lot of coding languages don't use degrees as units. They use radians, but this one uses degrees. So if you remember, there's 360 degrees in a whole circle. The servos that come with the Arduino kits usually are pretty chintzy, and they only go from 0 to 180. They don't go all the way around by default, so we can max out at 180. You can set your servo to 180, or you can set it to something smaller. But let's say if the button is up, then we'll say the servo is at its default position, which is 0. So we do s.write 0. And then otherwise, if the button is down, we'll turn the servo to a certain position. s.write 90. That's all the code. So if we have the button up, the servo does nothing. As soon as we push the button, the servo will turn. So you can see the possibilities of being able to modify the way that something moves based on your input and being able to interact with your own art, which is pretty cool. Let's start the simulation. Okay, so you can see the servo, they wiggle a little bit. They're getting a pulsed voltage that tells them what position to turn to, and you can't move them when they're locked in position like that. But if I push the button, it turns to 90 degrees. And then if I release the button, it goes back. Push the button, 90 degrees. Release the button, it goes back. You can also just make the servo move freeform in the same way that you do a blinky light. Do s.write 0, do a short delay, s.write 90, do a short delay. So servos can move on their own without any input from you, but this is just a way that you can make that movement interactive by pushing a button. So in the next video, I will show you how to use one last type of sensor, and then you've completed your Arduino activities for the week. Thank you.